Good afternoon. Today we'll see part B from question 18. In this question, it's asked the mass of the athlete is one of the factors that affects her time to complete the race. Explain why the mass of the athlete has little effect on the initial acceleration. Here again, the key term is initial acceleration. They're not talking about the entire acceleration of this journey, but only that's a hint here. All right. Now, how do we analyze or talk about the forces when the object just starts to accelerate? This you may have learned from IGCSE, or you might remember from the discussion in forces and in fluids as well. When an object starts to accelerate, the opposing forces acting on it. I repeat, when it starts to accelerate, the opposing forces on the object will be negligible. Right? It will be negligible. Remember this, which means this opposing force, in this case the frictional force or the drag, does not act on the object when it starts to move, right? So this can be eliminated, right? So we can remove that force. So the only force acting at the start of the journey will be in the direction of this movement. Now, keeping that in mind, here again you have got 3 marks. If you want to secure all three, you must mention about the first point would be the opposing force or the drag acting on the object is negligible. Now, coming to prove it theoretically, now uh, if you're talking about the resultant force acting on the object, that will be equal to mass multiplied by acceleration. And what is that resultant force at this point in time? The resultant force acting on the object in this case, since it's a component of force acting in this angle, we have seen that before, right? We have got friction force here, now it's negligible. So component of W will be acting along the direction of movement. Since this is theta, you will have the component along this to be sine theta. So you have mg sine theta will be acting on, right? I hope that's clear. So the resultant force is just mass into acceleration, which will only be equal to a component of weight, which is mg sine theta. So in this case, we can cancel out m and m. So you will have A is equal to A equals just g sine theta. So you've proved here the acceleration does not have any effect on, or sorry, the mass does not have any effect on acceleration. It just depends upon acceleration due to gravity and the angle with which it is inclined upon. I hope that's clear. So keep this point in mind. When the object starts to move, the opposing force is negligible. Hence, we can eliminate all those drag forces. It will only be the forces acting on the direction of journey, and you try to figure it out at that particular application, what are the forces acting in that direction, and that will be equated to m into a. So in this case, m is cancelled, so it has no effect on the acceleration of the object.